In the world of programming, one of the first big hurdles we all face is repetition. How do we get a computer to do something over and over and over again without us having to write the same line of code 100 times? Well, that's exactly where loops come in. And today, we're going to master these essential tools in C programming. So let's start with a little thought experiment, just to get our heads in the game. Imagine your task is super simple. Just print the same message to the screen 50 times. How would you do it without loops? Your first instinct might be, well, let's just say it's a bit tedious. You could literally just copy and paste that one line of code 50 times. I mean, it works, sure, but it's clumsy, it's incredibly inefficient, and what if you needed to change that message? You'd have to go back and edit all 50 lines. That just doesn't scale. Luckily, there's a much more elegant solution. Okay, let's open up our programming toolbox. Our very first tool is the for loop. This is your absolute go-to solution when you know exactly how many times you need to repeat a task. It's precise, it's predictable, and it is incredibly powerful. A for loop is basically a counter. You tell it three things: where to start, when to stop, and how to count from start to stop. This super clear structure makes it the perfect tool for when you know exactly how many steps you need, like, say, going through every single item in an array or every character in a password. The for loop operates like this perfectly disciplined machine, right? It follows a precise four-step cycle. Step 1, it sets up a counter, but it only does this once, right at the very beginning. Step 2, it checks a condition. If it's true, it moves on to step 3 and runs your code. But if it's false, the loop is over. Step 4, after the code runs, it updates the counter, and then boom, jumps right back to step 2 to check the condition all over again. Initialize, check, execute, update. That's the rhythm of the for loop. So let's picture a classic for loop. Imagine the code, you've got for, and then inside the parentheses we set an integer, we'll call it I to 1. That's our start. Then the condition is I less than or equal to 5. And finally, the update is I++, which just means add 1 to I after every single pass. It's this three-part setup that makes the for loop so easy to read and so predictable. So how many times is that code actually going to run? You guessed it, exactly 5. It runs when I is 1, when I is 2, 3, 4, and 5. The moment I becomes 6, that condition, I is less than equal to 5, is no longer true, and the loop just stops. Simple, right? But what happens when you don't know how many times you need to repeat something? I mean, think about it. Waiting for a user to finally enter the correct password, or reading a file until you hit the very end. For these kinds of unpredictable situations, we're going to need a more flexible tool. And for that, meet the while loop. Think of it like a bouncer at a club. It checks your condition right at the door. If the condition is true, you're in. The code runs. If it's false, nope, you're not getting past, and the loop might not even run once. It just keeps on running as long as that one condition stays true. A perfect real-world example is waiting for user input. Imagine a little program that keeps asking you for numbers and adding them up, and it only stops when you enter 0. The logic is simple. While the number you entered is not 0, keep on running. We have absolutely no idea if this will run once or 100 times. And that uncertainty is exactly what the while loop was made for. All right, now for a bit of a special case. What if you need to guarantee that your code runs at least one time before you even check the condition? For that specific job, we have a cool variation of the while loop. Okay, here's the key difference, and you gotta remember this. A while loop checks the condition before it runs. A do-while loop runs the code first and then checks the condition. This guarantees the code block will always execute at least once. It's perfect for something like a command line menu. You have to do the action of displaying the options before you can check while the user hasn't chosen to exit.
Okay, we've got our 3 main loops, but what if we need more control? What if we need to bail out early, or maybe skip a specific step? These aren't new loops, but think of them more like power-ups for the loops we already know.
Let's break these down. Break is your emergency exit. It completely terminates the loop, right then and there, and your program jumps to the very next line of code after the loop. Continue is different. It doesn't exit the whole loop. It just says, hey, skip the rest of this one iteration and jumps right back to the beginning of the next one. So imagine you're searching through a massive list with a million items, looking for the number 42. If you find it on the 10th try, do you really need to check the other 999,990 items? Of course not. You use break to get out of that loop immediately. It's all about efficiency. Now, for continue. Let's say you're processing a list of numbers, but you only care about the positive ones. When your loop hits a negative number, you don't want to stop the whole process, right? You just want to ignore that one number and move on. That's the perfect job for continue. So now that we have the tools, let's talk about craftsmanship. Writing smart loops isn't just about making them work, it's about making them clean, fast, and bug-free. So here are a few best practices to keep in mind. First, and this is a big one, always make sure your loop has an exit strategy. An infinite loop will just freeze your program. Second, be really careful about putting loops inside other loops. We'll talk more about that in a sec. Third, use clear variable names. It just makes your code so much easier for you and everyone else to understand. And finally, use break and continue sparingly. Too many of them can make your code's logic really hard to follow. And this is that performance cost of nested loops I was talking about. Programmers have a fancy term for it called big O notation, and a nested loop is often O(n) squared. Simply put, this just means the processing time grows exponentially. So if you double your input, the time it takes could quadruple. It can bring your program to a crawl very quickly. So to wrap it all up, here's a quick little cheat sheet for you. Use a for loop when you know the count ahead of time. Use a while loop for an unknown number of repetitions that depends on a condition. And use a do-while loop when you absolutely must execute the code at least one time. Ultimately, the goal isn't just to write code that works. It's to write code that's clear and easy for other people to understand. Choosing the right loop for the job is a huge part of communicating what your code is actually trying to do. And that's our deep dive into loops in C. As you go about your day, I'll leave you with this little question to think about. From scrolling through your social media feed to loading up a music playlist, what loops are running behind the scenes, making the technology you use every single day possible? Thanks for joining me.